Okay, let's discuss the modeling of the transportation problem, which is one of the linear optimization models that we will review in this chapter. Okay, so here we assume that we have m supply points and n demand locations. Okay, so we have m supply points and we have n demand locations. Okay, so basically suppose that these are my supply points and these are my demand locations. So I have supply point 1, 2, 3, all the way to m, and I have demand point 1, 2, 3, all the way to n. Okay. Now, I define xij to be the amount shipped from supply point I to the demand point j. Okay, so x sub ij is the amount shipped from supply point I to demand point j. And then I define Cij to be the cost to ship 1 unit from supply point I to demand location j. Okay, so Cij would be the cost of shipping 1 unit from supply location I to demand location j. Okay, so for example, if I want to ship from supply point 2 to demand location 1, okay, in this case, the cost of shipping 1 unit would be C21, and the amount shipped from supply point 2 to demand point 1 is going to be X21, okay? So the product of these two, X21 times C21, would be the total cost of shipping from point 2 to demand supply point 2 to demand point 1. Okay, now that we know that Cij Xij is the total cost of shipping from supply point I to demand location j, if we sum all these terms over all supply points and all demand locations, we have the objective function, which is the cost, the total cost. Okay, so basically my total cost will be equal to double sigma I from 1 to m and j from 1 to n Cij Xij. Okay, in other words, if I want to simplify it a little bit, this is going to be C11 X11 plus C12 X12 plus all the way to CMN to XMN. Okay, shipping from all the supply locations to all the demand locations. This is going to be my total cost. Okay, so what is my objective? My objective is to minimize this total cost. So my objective is to minimize the total cost, okay, which is given in the top here with these two formula. Okay, so now if I want to approach this mathematically, the absolute minimum of this would be 0. I can just plug in 0 for x11 and x12 and all the way, and I will get a 0 cost, which is minimum. Okay, obviously this is not the answer. I have some constraints. Okay, I have to ship all the required amount from the supply points to all the demand locations. Okay, and also I cannot ship more than the amount available at each supply point. Okay, now these are going to be my constraints. Okay, so for introducing my constraints, I need to define a few things. First, I need to say that SI is the supply available at point I. Okay, so SI is the supply available at point I, and D sub J is the demand required at the demand location J. Okay, so demand required at demand location J. Okay, so based on this, I have these constraints. First is the supply constraint. Okay, supply constraint is that we cannot ship more than the amount available at each supply point. Meaning that, so first let's go ahead and talk about the supply constraint. Okay, so supply constraint would be that, for example, let's talk about supply point 1. Okay, x11, meaning the amount that goes from supply point 1 to demand location 1, plus x12, amount that goes from supply location 1 to demand location 2, all the way to x1n, which is the amount that goes from supply location 1 to demand location n. This cannot be more than what is available in supply point 1 or S1. Okay. Same thing for supply point 2, x21 plus x22 plus all the way to x2n should be less than S2, and all the way to from supply point M, whatever goes out of supply point M to demand point 1, demand point 2, all the way to demand point N, which is xmn. This should be less than Sm. Okay, so these are my supply constraints. Same analogy, I will have demand constraints. Okay, so demand constraints basically state that all the demand required at each of these demand points need to be met. Okay, we ship the required amount from the supply points to each demand location. Okay, meaning that, for example, the amount that goes from supply point 1 to demand point 1 plus the amount that goes from supply point 2 to demand point 1 all the way to supply that goes from supply point M to demand point 1, this should be exactly equal to demand in location 1. Okay, same thing for demand location 2. Supply from point 1 to demand location 2, x22 plus all the way to xm2. This should be exactly equal to d2. And finally, the supply that goes from supply point 1 to demand location n plus from supply point 2 to demand location n all the way to supply that goes from demand location supply point m to demand location n should be exactly equal to dn. Okay, so these are my supply constraints and demand constraints. Okay, another thing that I need to apply here is that obviously my xij cannot be negative. They are all positive. These are technicalities of the optimization. And so this applies for all the values of I going from 1 to m and j going from 1 to n. Okay, so this is basically the layout of my transportation problem. So based on these two constraints that I have here, demand constraints and supply constraints, I want to minimize the total cost, which is given by this formula. Okay, how do I do that? I basically can go ahead and solve this manually. It is possible to solve it manually. However, it is, first of all, it will take forever. And secondly, it is redundant. We don't need to solve these things manually at this day and age. We can use the Excel template that is available to us to solve this problem.